And I would like to officially welcome our special guest. We have John Connolly all the way from NASA at the Houston Space Center. Is that correct?
That is correct. Greetings from Houston.
Welcome, welcome, and thank you for joining us. We also have a whole bunch of guests that are scattered around the world, and a few guests that have joined us live in the Hangout as well, and hopefully we'll get a few more people joining in as the Hangout proceeds. For those of you who don't know, the Humans to Mars Summit is going to be taking place from the 8th of May to the 10th of May, and John, I believe you're going to be speaking there, is that correct?
I am. My job at NASA is actually leading NASA's planning of how we're going to send people to Mars. So we have a few big meetings every year where we talk about how we're going to do that.
And obviously the Humans to Mars Summit would be one of those important meetings, because you get academics, you get scientists, you get everyone together to come and even the movie industry, because there's a sense that's coming together quite nicely with the science.
The movie industry loves Mars. There have been lots of great movies about Mars and some bad ones, but it's exciting stuff. And the movie industry likes making movies about exciting stuff and people doing extraordinary things. And going to Mars will certainly be an extraordinary thing.
Awesome, awesome. So before we get to the whole Mars thing, I want to go back in time. Every superhero has an origin story. So you landed up going into the sciences. Can you tell us a little bit about your journey, how you got there? Was it easy? Was it difficult? What were the kind of things that you had to do to get to where you are today?
Well, I'm an engineer, and so I've always liked building things and putting things together and solving problems. And my journey started when I was about 9 years old, because back then that was 1969, and that's when two guys named Armstrong and Buzz Aldrin were walking on the moon, and that got me very interested in NASA and space. Of course, back then everybody was interested in space. But one other big thing happened back then. I discovered something called model rockets. And model rockets, if you haven't ever played with them, are kind of toys, but they have real rocket motors in them that make them go really high into the air, and they go really fast, and they come back on a parachute. And I thought that at 9 years old, that was the coolest toy anybody had ever invented, that you could actually, build these rockets and shoot them into the air, and they come back and you shoot them back up again. So I think a combination of growing up in the Apollo age with people walking on the moon and having all these cool space toys to play with is what got me started. And now it's a couple of years later, and I'm here working at NASA, and my job is to plan how we get people to Mars.
Now, before you doing the Mars aspect, you were doing something else at NASA before that. Is that correct?
Well, I've done a number of things here at NASA. I used to work in the astronaut office. I was the only non-astronaut in the astronaut office. They needed a good engineer, I guess, to help them with a lot of things. So I worked with all the astronauts. For a while, I was NASA's chief exploration scientist, which meant that I was kind of the engineer who talked to the scientists and knew how to talk between engineering and science, because sometimes those groups don't always know how to communicate with each other very well. And I was also the leader of a team that was designing the next land. And so one of the things I do in design spacecraft, and I design space missions. So those are that's kind of been my career at NASA. But I haven't sent anybody to Mars yet. That's what I want to do.
And well, I mean, here's a tough question. When do you think that's going to happen?
Well, so it's a two-part question. We could send somebody to Mars in the next 10 years if we really wanted to. I don't think it would be kind of a risky mission. It wouldn't be the most technologically advanced way to get a person there. I think if we did a little more work on technology and rocket propulsion and life support systems, we would probably come up with a little better Mars mission, maybe if we took 15 or 20 years from now to get there. But that's the technology part of it. The other part of a Mars mission is somehow you have to pay for it. And the way big space missions are done usually is that big countries like the United States and Russia and China and others have space agencies, and those space agencies get together and they have big programs like the International Space Station. And so the other part of the problem, the first part is technically how do you do it. The other part of the problem is how do you get all the countries together? How do you get all these new companies like SpaceX and others that want to go to Mars? Get everybody together so that we're all working, towards the same goal of getting people on Mars. And that's a little trickier because that involves people and governments and politics and some of that stuff that is kind of hard for an engineer to keep track of.
I can imagine. But now when you say visit Mars, are we talking colony? Are we talking popping in to say hello and let's check out what's going on and then go back again? What are we talking about?
Well, I think it's going to go in stages. I think the first missions to Mars will be short, and by short I mean they'll maybe we'll be on the surface of Mars for a month. Okay, that doesn't sound like a short one, but when you think about it, a whole Mars mission takes about 2.5 years to get to Mars and orbit it and go down to the surface and then to get all the way home to Earth. So of that 2.5-year mission, the first missions will probably spend about 30 days on the surface. And then I think we'll gradually increase that to where we're spending maybe a year or more on the surface before coming back. And eventually, at some point in the future, we'll have habitats on the surface and power systems and rovers and all the things that we would need to stay even longer. So at some point in the future, we'll have enough infrastructure, enough of living space can stay permanently at some point. But I think you start out with short missions and be up to longer and longer missions.
That is amazing. Well, I mean, I'm very excited. We've got quite a diverse audience. We've got audiences from South Africa, from the USA, from Nepal. We've even got from Hungary that's just joined us, Dondi. So, I mean, I can ask you lots of questions, but I want to give people a chance to ask some questions. So I'm going to start off with Tanya's group. Do you want to get one of your kids to ask a question? You just have to unmute yourself and then pick a volunteer.
All right, Dakota, come on up and ask a question. Thank you, Steve. And what's your title, Mr. Connolly? Director?
My title is the lead of NASA's Human Mars.
All right, this is Dakota.
Hi. Hi.
What's your question?
How long does it take to travel to Mars or space?
Okay, I got travel to Mars. What's the rest of that?
And to space. I mean, that's it's not a simple question to answer because it depends when you travel to Mars.
Okay.
Thank
you.
you.
I didn't get the whole question. All I heard was travel to Mars.
So she wants to know how long does it take to travel to Mars?
So that's a really good question. So you know that the Earth rotates around the sun. It orbits the sun. And Mars also orbits the sun. But the Earth and Mars orbit the sun at different rates. It takes, for the Earth, it takes us 300 years. A Martian year is much longer than that. And so in order to go to Mars, you have to wait till the Earth and Mars come into the right orientation with each other so that you have a nice, easy trip out to Mars. That happens about once every 26 months. And in fact, it's about to happen here in May. You're going to see a bunch of news about spacecraft being launched to Mars because the Earth and Mars are just in the right position for us to go. So once every 26 months, we can go to Mars. Now, once we get there, let's say we send you there. Once you get there, the Earth is not going to be in the right position to come back anymore. In fact, you're going to have to kind of wait on Mars for the Earth and Mars to get into the right alignment again so you can come back. And that means that you're going to stay either on the surface of Mars or in Mars orbit for something like a year or a year and a half, waiting for the planets to line up again. And then you come home. So if you think about a mission, your mission out is maybe going to be 9 months, and then you're about a year and a half on Mars, and then maybe 9 months. And you can't do anything about that. That's just the physics of how the planets are. I suppose if we had warp drive like they do on some of the science fiction shows, we could do better than that. But with the kind of propulsion systems we have now, a Mars mission is going to be a long mission. And once you burn your engine to leave to Mars, Sir Isaac Newton is driving your spacecraft now. You're not, you can't just come back anytime. So once you burn your engine to go to Mars, it's going to be 2.5 or 3 years before you come back to Earth.
Wow. Well, that was a great question, Dakota. Let's go to Natasha's group. Natasha, do you want to get any of your kids to ask a question? They're very excited about asking a question. You just have to unmute yourself. You can just click on the microphone at the top so that we can hear you. There we go. That's it.
Hello, John. So my name is Mac. I want to know
Oh boy, we didn't hear you very clearly there. So we'll try it one more time. Just speak nice and slowly. Sorry, I muted you there for a second. Let me unmute you. Try it again.
Hello, John.
Oh, well, hey, so we wanted to know how close are we to finding water on Mars? Like, what kind of excavation would you have to do to find water on the surface of Mars?
Okay.
That's really good.
That was a good question, and I figured out we had two people talking at the same time. That's probably why there was confusion. We'll get back to you, Natasha. Don't worry, we'll get back to you. Okay, John, all yours?
Right. So let me answer the water on Mars question. So water is one of those things that's very important as we send people out into space because, we as humans need water to survive. We need it to drink. Water contains oxygen, which we can break out of water to breathe. And the hydrogen and the oxygen in water also makes a very, very, very nice rocket fuel. Okay, you get hydrogen, you get oxygen, you put them together in a rocket engine, and it's a really, really good rocket fuel. So finding water anywhere out in space is very important. On Mars, we just had a very significant water announcement about a month ago, and you can find this online. We found glaciers on Mars, and I'm not talking small glaciers. I'm talking big, thick, 150-meter thick blue ice glaciers of water. So that was huge news. Just do a search on Mars ice glaciers, and you will see the color picture of a blue ice glacier on Mars. So Mars has lots of water. It's typically under a layer of soil. That's what keeps it from sublimating away, from boiling away in the very thin atmosphere. And it's very easy once you find a deposit of ice to be able to extract water from it. All you need to do is put a hot kind of probe down into it, melt some of it, and pump it up to the surface. So we're really, really excited that we found very large reservoirs of accessible ice on Mars. And I think that's going to make a big difference about where we go. So we know that if you're near the equator of Mars, it's warmer, and the ice will be buried much further underneath the ground. As you get closer to the poles, the ice gets closer to the surface until, well, you see polar caps on Mars, so where the ice is actually above the surface. So if you think about it, from the North Pole of Mars all the way down to the equator, the ice is getting buried more and more under the dirt. So at about 40 or 45 degrees north latitude or south latitude, works the same in both hemispheres, that's about where the ice is, just below the surface. And anytime you get a little bit of a surface fault, you know, and some of the dirt falls away, we start seeing in the sides of craters and the sides of canyons this exposed sheet of very blue, pure ice. Pretty amazing, and it's worth a look online.
But now, of course, if we test the water, would it be pure drinking water, or would it be something containing? Oops, sorry there. I think Joyce and them have to go.
Okay, that's all right. So we don't know. What we know is we've taken a picture, and we've seen a thick glacier of blue ice, and the readings we get from our instruments in orbit tell us that it's ice. But what we don't know is exactly, does it contain any other chemicals? You know, is it, I don't know, lemonade flavored ice? I don't know. So we're going to have to go there and test it. But just finding that much ice is an amazing thing in itself.
I agree. So now we're going to go back to Natasha. We're going to try our luck again. So you're going to unmute yourself and maybe turn your speakers down a little bit, because I think it's the echo of the sound coming through the speakers. And now try.
Okay, so when astronauts are in space, how do you ventilate the air so that they don't wake up with coughing and gasping, like so that carbon dioxide isn't above them and they're breathing in carbon dioxide only?
John, did you get that question?
Yeah, I think it was about how do you control the levels of carbon dioxide in your atmosphere so you don't wake up with headaches and things like that. Well, that's actually a really good question, and that's something we have to deal with on the International Space Station right now as well, because we actually do let the amount of carbon dioxide in the atmosphere of the ISS be a little higher than it is in your classroom right now. And so this is where life support systems become very important. There's a couple things you have to do to make an atmosphere that people can live in. You need the right pressure, of course. It can't be too thin. You can't live in a Martian atmosphere because it's only about 1% of the atmosphere of Earth. You have to have the right amount of oxygen so we can breathe. And so here at sea level, we have about 21% oxygen in our atmosphere, and so that's about what you need to keep people healthy. And the other thing you need to keep the other gases in the atmosphere in balance. You can't have too much carbon dioxide. You can't have other gases, of course, that are harmful to us. So control of carbon dioxide is one of those really important things, because, as you said, the more carbon dioxide you get into the atmosphere, you start getting headaches. You start not being able to think very well, and you could actually be poisoned by the carbon dioxide in the atmosphere. So one of the things we do a lot of work on is our life support system technology that actually extracts the carbon dioxide from the air. And there's a couple ways to do this. Back in the early days of space flight, we would do it with chemicals. There are actually chemicals that want to attract carbon dioxide and bond with carbon dioxide. And that's one way of controlling it. Unfortunately, once that chemical is used up, you have to sort of throw it away and bring new buckets of chemicals up. The way we do it these days is there's two really. There are some chemicals we use that like to attract carbon dioxide, and then once they're kind of full, if you think about it, it's kind of like a sponge. When it's full of water, we vent it to the vacuum of space, and all the carbon dioxide vents out of the sponge, and then we reuse it. Another thing we do is we use something called the Sabatier process. And the Sabatier process is a very old chemical process where you combine, where you take hydrogen and carbon dioxide and you put them together, and it creates methane and water vapor. And so it likes to attract carbon dioxide. And so there's a way to use the Sabatier process to take the carbon dioxide out of the atmosphere, make methane with it. And, methane is good for rocket fuel also, or you could just vent it. And then it makes water. And of course, the water you could just use, or you can break it down into the hydrogen and oxygen that it's made of, and use it for other things. But keeping those systems running is actually one of the biggest challenges we have on the International Space Station right now. And it's one of the biggest challenges we'll have when we go to Mars. Well, educated question, though. Thanks.
Great question. So now we're going to go to Kim in Ivory Coast, in Cote d'Ivoire. Let's have a look. Kim, you're going to unmute. There we go.
Okay, hi, thank you. We're happy to be here. We have a small group with us of 6th graders, and they have some questions for you. Come on up. Who wants to go first? Vanya? This is Vanya. Come on up to the camera.
My question is, how long does it take for you to prepare to go to Mars?
Now that's
Okay,
an interesting question.
That is a good question, Vanya. Thank you. Well, I've been preparing to go to Mars for a long time now. But let's talk about training an astronaut, because I think that's what you're talking about. When we train astronauts to go into space now, we typically train them for about 2 years, 2 to 3 years for their missions up on the International Space Station, and those missions typically last 6 months. When we're going to choose a crew to go to Mars, it's going to be a very special group of people, because first of all, it's going to just be 4 to 6 people on a mission. And those people are going to have to get along very well. And they're going to have to know how to solve a lot of problems along the way, because there's no gas stations in space to stop at. So we're going to pick 4 to 6 people who get along very well with one another. Maybe, I think I count about 6 of you there. That looks like a good crew. So they're going to have to get along very well. We're going to put them in lots of training where we put them in situations where they have to count on each other to survive. So the training for a Mars mission will probably be much longer than the training for a typical space station mission. I would guess it's going to be at least 5 years to train a crew to go to Mars. And that's because they're going to have to not only have to train to become a good crew and good friends, but they're going to have to learn how to operate their entire spacecraft and how to do science once they get to Mars. So if you think about all the people you need to survive for 2.5 or 3 years, you need a doctor, you need pilots, you need engineers, you need different kinds of scientists that you'll need when you get to Mars. And you add up all those people and you probably get 10 or 15 different kind of people you need, because you can't just take one doctor. What if the doctor gets sick? You need someone else who knows how to be a doctor. And so somehow you're going to take all the experts in 4 to 6 people, that stuff. So it's going to take a little while. And so I'd say that once we pick the first crew to go to Mars, they're probably going to be training together for at least 5 years.
Sure. Great question. Now we're going to ask you guys to ask another one. Don't worry, the others, we will come back to you. Okay, Kim, you want to unmute, and then who's going to ask the next one?
Hello. So my question is,
Say your name.
my name's Chembo. So have any kids, have any teenager or anything younger than 18 been on a spaceship before?
That's a good question.
This is an interesting question.
So the answer is no, not yet. Okay, so I think what we're doing is we're waiting for you. Typically the people who go into space now are people who have been to college, who have not only degrees, in engineering or science, but they're also people who have some experience as well in putting their education to work. So, so those are the kind of astronauts we have today. I think before very long, you're going to see a lot of people going into space that are much different than the typical kind of astronauts that we have today. I think we're going to start seeing people who are just going to go into space to have fun, just to ride a rocket into space and float around and come back and take pictures and tell us all about it. And I'm pretty sure that you're going to see the first teenager in space. Now, if you want to become a professional astronaut and go to Mars, I think you still have to go to college, and do good in science or math or engineering, and go into lots of training to become an astronaut. But I think if you just want to fly in space, I think there's going to be lots of opportunities in the next decade that any of you will be able to fly in space at some time in your life.
Awesome, awesome. So we're going to switch over to Joe. Do any of your students have any questions? I'm sure there must be plenty of questions coming from the middle school.
Definitely. You got one right here. Come on up. That'd be nice and loud. There's your microphone.
Hi, my name's Quinn from Pennsylvania. If you go to Mars, what kind of rockets are going to be used to get into space in Mars?
So did you get that? What kind of rockets would you use?
Yep, I got it. So thanks, Brett. You've probably seen recently a lot of SpaceX launches. If you pay attention to, some of the cool stuff going on in space. I think the answer to your question is we're going to use every rocket that's available. So when we're talking about going to Mars, we think about it in terms of how much mass of stuff do we need to launch into space to take us there. Okay, and that means that we need rockets, we need the fuel that goes in the rockets, we need landers, we need a habitat that's going to take you on that 9-month transit. We need everything that goes on the landers that's going to go down to the surface. When you add all that stuff up, we're talking probably something on the order of 400 tons of stuff that you're going to have to launch into space. And right now, the biggest rocket we have in the world is probably the Falcon Heavy that launched not too long ago, last month. That could probably lift maybe 30 or 40 tons into space. Wow. When it's fully fueled. And so that means that we need 10 of those just to start a Mars mission. There's a couple bigger rockets that are being worked on right now. NASA's working on one called the SLS, the Space Launch System. And that's going to be the biggest rocket ever built. It's going to be even bigger than the Saturn V that took us to the moon a long time ago. The SLS will be capable of lifting 130 tons into orbit in one shot. So it's going to be a big rocket. And if you ever get to watch a rocket launch, that's going to be one to watch. There's also going to be big rockets built by companies like SpaceX and Blue Origin and others that are going to be part of it as well. Because sometimes you need to launch big stuff, and sometimes you need to launch smaller pieces of cargo. So I think there's lots of big rockets. There's lots of medium-sized rockets out there. We need a couple big rockets. And a lot of other countries in the world have rockets that we're going to use too. The Chinese are working on a big one called the Long March 5. That's going to be a fairly big rocket. The Russians have designs for some new, bigger, heavy lift rockets. And a couple of the other space agencies around the world are looking at kind of upsizing their rockets a bit. So the thing about sending people is you need a lot of mass in space to send people. And if you're going to go to Mars, you need even more mass because you need lots of fuel.
That is a great question. So now we're going to go all the way to Nepal. Swalicha, she's got a question. You're going to unmute. Yep, there we go.
Namaste everyone. Myself Swachalika from Nepal. As John works in NASA, I have a question. I have read in the news a couple of days ago. Someone from Nepal has bought a piece of land in Moon. How much land? How much land has NASA already sold it? Uh, is the NASA who does the deed? If not, who does that?
Now that is a fascinating question.
That is a great question. So there are places where you can go on the internet where you can purchase land on the moon. Unfortunately, I think the only thing you actually purchase is a piece of paper that says you own land. There is actually an international treaty that's been signed by most of the nations in the world that says that the moon is to be treated as an international science base, that no one could own parts of the moon. So it's very similar to the treaty we have that governs how the Antarctic, the South Pole, is used. No country has sovereign claim over any part of the Antarctic. We have scientific bases. Many countries have scientific bases there, but no one owns Antarctica. And so the Moon Treaty is written to be very much like the Antarctic Treaty, where the moon is to be a planet where scientists go and study it, but that nobody owns it. So I think if you like a piece of paper that says, yes, I own this little piece of the moon, I think you can get those on the internet. But I don't think that if you showed up on the moon and tried to actually claim it, that anyone would think that your claim was real. But that's a really good question.
Wow, so you think he might have been a little ripped off, but depending on what he paid for it. Now, I was thinking, Dondi, do you have any questions? Or do you want to hand over to the kids to ask?
Oh, me?
No, I'm just asking Dondi from Hungary. Dondi, you have a question?
Yes, maybe I need. Can you hear me?
Yes. Yeah, we can hear you.
Okay. Are you planning to take any small animals or small seeds to space in the future, just to see how they change?
Okay.
Well, that's a very good question as well. We actually take small animals up to space all the time, and some of them are really, really small, and some are, more the kind you can hold. There's been quite a few mice and rats who have flown to space, to the International Space Station. We actually have a facility. Yeah, we study how their bones they grow. We take them up as very small mice, and we watch how they grow to see how microgravity, how being without gravity affects the growth of their bones. I believe we have taken fish up to space at least once, and the newest member of the International Space Station that's going to go is a very small animal called a tardigrade.
Uh-huh.
And so if you look up online what a tardigrade is, tardigrades are these very very robust little microscopic creatures that look like little bears. And they can survive radiation, and they can survive boiling water and the vacuum of space, and they just keep living. That you can't kill a tardigrade. And so we're very interested in knowing what it is about these small little strange looking animals that makes them so very tough. Now, to finish the question, we've never actually taken any big animals with us. So really nothing bigger than a mouse or a rat has ever gone to space, other than some of the early animals that were launched early in the space race, like the monkeys and the dogs. But as in terms of going to space station, it's been small animals ever since. But that's a good question. Thanks.
All right, we're going to go back to Tanya's group, and then we'll go to Natasha again. Tanya, do you have anyone in your class who would like to ask something?
Anna does. All right, go closer. Tell your name.
Hi, I am Anna. When will regular people be able to visit Mars? And what could we do to prepare?
Did you catch that?
I got the first part of that. Will we be able to visit Mars? And I think
When will regular people be able to visit Mars, and what will they need to do to prepare?
Okay. Regular people. So, so typically, anytime we talk about going to a place like Mars, we kind of assume that there's some people who have done the exploring ahead of time and have set up something so that normal people can go visit. So let's think again about the Antarctic, okay? Because I think this is a good, kind of a good example. We've been exploring the years now, and now we're just getting to the point where you can get on a boat and cruise to the Antarctic, not being a scientist, just being a tourist. So it took about 100 years since the first people visited, the first explorers visited the Antarctic until normal people, were going as tourists. And so, that sounds like a long time. It's not in the big picture, but that's probably about the right time scale for something like the Moon or Mars. That it's going to take quite a while and the things, but also to build up the transportation, the rockets that will safely get you there before normal people, will want to go. Most normal people, even though they say they'd like to go to the Moon or Mars, when you tell them about all the things that could potentially harm them, many of them all of a sudden don't want to go anymore. So astronauts are very brave people. They accept risks that maybe it's not quite as safe as it is here on Earth. But when we get the safety to a level that people that's good for people, I think they'll start going there. So it may happen sooner than that, and you may get to see it in your lifetime. Normal people going, but one thing I guarantee that you will see is you will see people going to Mars in your lifetime, and that'll be very exciting because going to Mars is probably the most difficult thing that humans would have ever done. It's a very, very hard, by comparison, is actually pretty easy compared.
Okay.
I think you're going to see a lot of interesting things.
All right, we're going to switch over to Natasha's group.
Hi, I'm Amy. My question is, well, the trip to Mars takes a really long time. So the sleeping situation should be really important. How could we improve on sleeping on a wall?
Well, sleeping on a wall sounds like the best way to sleep. Why would you want to improve it? So it's a thing. Some astronauts like having personal places to sleep. A little sort of a phone booth where they can zip it up, and it's dark, and they could just kind of strap themselves to the wall. Some astronauts like to actually have pillows, but since pillows float away, they actually use a piece of Velcro across their head to keep the pillow attached to them, but they just like the feel of having a pillow. Other astronauts don't actually care where they sleep, and they actually just kind of jam themselves into a corner and just fall asleep and just enjoy, floating. Other astronauts like looking out the window, so they like falling asleep near the windows, so they can look out at space, when they wake up and as they fall asleep. So sleeping is a very personal thing. So it's hard to say how we improve on the whole sleep experience. Astronauts typically do sleep very well because you think about when you go to sleep, you lie on the bed, and gravity, of course, is holding you down and like me, you in the middle of the night. Well, in space, you don't have that gravity holding you down. It's probably very, very comfortable to sleep in space because it's like floating. So the next time you're swimming, jump into a big pool of water and go underwater and just let yourself float free. And, without touching the bottom or without coming to the top. That's the way it feels to sleep in space. It's probably very, very comfortable.
But now, obviously, if you're doing a long journey to Mars, would you be sleeping for more than the regular time that you should? You watch all these science fiction movies where they get these people to go into sleep chambers and then they wake up several months later, depending on how far they're traveling.
Yeah, so that's science fiction. We haven't figured out how to put people into hibernation yet. Typically, what we do in space right now for the crews that are up for 6 months at a time, they work on a regular 24-hour day. And so they sleep for 8 hours a day, and they work for about 10 or 12 hours a day, and then they have a couple hours for exercise and for eating and things like that. So they're on a normal 24-hour Earth day. And by the way, they use Greenwich Mean Time as their clock. So if you're wondering what time it is on space station, just look up what GMT is. When we go to Mars, we have a very interesting situation that a day on Mars is almost exactly the same as an Earth day, but it's just a little longer. It's 24 hours and 37 minutes. And so maybe that's the perfect sleep day because you still have you get 37 extra minutes to sleep every day. So
that
it's like
sounds
having
like a perfect day.
like having a snooze button. And so for the crew on Mars, they won't really notice the difference between 24 hours and 24 and a half hours. But the people who will notice will be the people on Earth who are the mission controllers, because every day is going to get 37 minutes longer. And that means that the people who do mission control have to be on Mars time. So I think it will actually affect the sleep of the people here on Earth more than it will affect the sleep of the people on Mars.
Now, before I hand over to the next group to ask a question, as you know, Scott went up to space for a year. And when he came back, they did some analysis and found that his DNA was different to his brother. What is fascinating about that is because, you're going to have long duration trips traveling there and spending time and possibly, a 2.5 year round trip to get there and back. Are we talking about aliens coming back? They depart as humans and come back as aliens? What's the story there?
So a little bit of misinformation in how that was reported. When so we had two twins. One went into space, one stayed on the Earth. When they came back, when the one came back from space after a year, they measured all the things about them to see how they were, how space might have changed them. And Scott Kelly, who was in space, they measured his DNA, and it's not true. His DNA was exactly the same as his brother.
It's so ridiculous.
I know. And so what changed is something that they call gene expression, which is how your DNA sort of reacts to zero gravity. But the DNA itself was unchanged. And that's a good thing, because DNA is, you change this one little bit in the genetic code, and all of a sudden, instead of being a human, you're a piece of grass, right? Because, 92% of the DNA of all plant species is the same. So it's only that last 8% that actually makes us unique. So if we actually changed 7% of Scott Kelly's DNA, he very well could have been a springbok, I suppose.
Well, maybe he can play decent rugby.
But he wasn't. So yeah, that unfortunately was lost in the details. His DNA didn't change, but there's something called expression of genes that changed a little bit, and typically went back to normal once he got back to Earth. So he's the same guy actually who left, and I see him. He looks exactly the same.
Okay, let's go to Ms. McNulty. Have you got someone in your group that wants to ask a question?
Ladies and gentlemen, anyone? Oh, I do have a question for you, though, if I could ask one.
You can.
I was wondering, because it's such a long journey, and I know we've had people in space for extended periods of time, are they thinking about trying to do artificial gravity or anything for such a long journey? Or is that just too hard to do, too hard to engineer?
So you must have some engineering background or be a very good STEM teacher.
He's a very good STEM teacher. Very good STEM teacher.
So, artificial gravity is one of those things that's easy to talk about and actually very hard to do. So it's easy in concept. You spin, you spin the habitat that the humans are in, and you do the right calculations with the spin rate and the distance from the center of rotation, and you could calculate how much gravity. It's not actually gravity, but it's centripetal acceleration, actually, you experience. And so it feels like gravity. It's actually acceleration. You could do that. And there have been experiments here on Earth where we've put people in rotating rooms and actually made them live at higher gravity levels. We've never actually done the experience in space where we've put a habitat on the end of a big string and spun it around and made artificial gravity. Now we could do that. It's simple in theory to do. The problem with it is if you do that, you're solving one problem, but you're creating about 10 other problems. So the one problem you're solving is how gravity affects the human. Okay, you put a human back in a gravity environment, and all of a sudden, yeah, you could walk, you could drink away. You could sleep on a bed, all the things that we know of here on Earth that involve gravity, you could do in space if you had artificial gravity. The problem is, though, you're inside a big spinning spacecraft, and now it's very hard to dock things to you because you're spinning. You may have to dock. That means to spin it and then spin it down. You have some challenges in pointing your propulsion system. Where are your engines, and how do you point them in the right way to move your spacecraft? How about your communications antennas? You want those fixed on the Earth, and if you're in a rotating system, that's a lot harder to do. And there's probably about 6 or 10 other big inches you have because you're in a rotating system. In fact, there's a lot of the rules that have to do with how you control a helicopter now start coming into play for your spacecraft because you're in a rotating system. So yeah, you could do artificial gravity, and it will solve one problem, but it will create about at least 10 other big challenges for your engineers.
Well, there's a very simple solution to it. You either apply a downward suction like they use in the toilets in the space station, and that would allow people to have the sense that they are being pulled towards a certain side of the rocket, or magnets. You place lovely magnets in the soles of their shoes, and whoosh, they just stick to the floor.
You could do that, but that only helps stick you to the floor. That's effective gravity. Make your bones work. It's not going to make your heart work harder to pump the blood around. It's just going to give you the effect of standing on the floor. So the reason you want artificial gravity is because you want that acceleration to help your bones and your muscles to stay strong, and your heart to keep strong by having to pump blood against against gravity. So it's more than just keeping your feet on the floor.
So it's quite complicated. Okay, let's go back to the Ivory Coast. Let's see if Kim, have you got something you want to ask?
Sarah, come on up. Yes, we do. Say hi, your name.
So, hi, I'm Sarah. So my question is, are you guys working on trying to chemically modify plants to fit space's atmosphere so we can just grow crops there or on the moon or on Mars? we don't have to go back to Earth to get food. Are you guys like trying out that?
Did you hear?
I got about 60% of that.
Okay, try again, but speak.
Did we get the rest?
It's about growing plants on Mars, and so that we don't have to go back to go and fetch food. Are we able to develop our own and something to that effect? Is that correct, Sarah? Okay. I think you muted. Just unmute yourself. If you click on the microphone. There we
She's
go.
asking if they're genetically modifying or chemically modifying foods in order for them to grow in Mars. I think that's the question,
That's
right?
a good question. Very good question.
Okay.
That's an excellent
Yes, well, that's a more interesting question than just growing ordinary plants. So the answer is yes. We're already doing some work on that. When plants, first of all, plants I think are going to be really important in space for a number of reasons. Humans just like being around plants. They just like having green things growing around them. On the space station right now, we have a lettuce machine, a salad machine that grows lettuce, and the crew like doing that. They like tending to it and making sure the lettuce is growing good, and of course eating the lettuce. But once we start talking about Mars, it's more than just the comfort of having plants with you. You also want to be making food. And so that's ultimately why you would want to take plants. And so if you've seen the movie The Martian, you know that they grew potatoes in The Martian, and that is one of the things we might be able to grow. But what you're talking about, do we modify them genetically a little bit? And the answer is probably yes. And the reason we do that is because here on Earth, a lot of the plants that we grow have a lot of non-edible stuff that grows with them. So if you looked at a wheat plant, for example, wheat plants are very tall, but it's only the little bits of wheat at the very top that are that you would typically till back into the soil. So we've done some work at NASA with some of the agriculture people looking at how to grow wheat that's only this tall, and it's all the wheat part with almost no stalk at all. So it's called apogee wheat. That's an excited type plant that we might take into space because you get a whole lot of edible material out of it with very little left over. So I think because everything we do in space depends on us, using mass, using water very carefully. When we start growing plants, we're going to have to come up with plants that use water and resources very efficiently. And so, yeah, I think that will require some very specialized plants.
That was a super question. Great question. Let's go to Dondi. I can see you've got your son there. Maybe he wants to ask a question.
Okay. Can you hear us?
Yes.
Yes.
Yep.
Okay. We asked, how do you count the time there? Do you check a watch? That's okay. But is the time the same? For example, when you return back, is it the same as you counted? Can you understand it?
Yes, I do.
Okay, you are connected, but it can be quite different. How do you know that the time is going, for example, 1 day, 1 week, 1 month? And is it the same when you return back?
Good question.
Okay, so time is an interesting question. Typically, when we send people into space, we keep them on the same time clock that they have here on Earth. As I said before, the people on space station right now are on Greenwich Mean Time, so it's no different for them. They're almost at the same time you guys are at, I think. if you're in South Africa.
Well, we GMT +2, and Europe, Gandhi in Europe is about GMT +1, maybe with the clocks turning back, that might change a little bit.
That's true. But the so we try to keep everyone on a 24-hour day, and difficult for them because orbiting the Earth, they're going into the shadow of the Earth once every 90 minutes. So you have nighttime every 90 minutes, and then 45 minutes later, the sun comes up, and you go through it all again. 16 times a day, you get sunrise and sunset. So we impose a clock on them, and they get quite used to it. When they go to sleep, they make sure they put themselves in a dark place so they don't see the sunrise every 90 minutes. And they keep track of time pretty much like we do here on Earth. I think when we go to Mars, we will adapt to when you land on another planet, that's when I think you have to adapt to that planet's clock. So when we go to Mars, the day will be 24 hours and 37 minutes long, and the year will be 600 some days long, because that's how long it takes to go around the sun once. So I think that we will adapt to the local conditions, and that's how we will count days. In fact, there's a different word for days on Mars. We don't call them days; we call them sols, S-O-L, which means the amount of time from one sunrise to the next sunrise. That's a sol. And so whenever you look at, say, a website that's talking about Mars rover, like the Curiosity rover, it will tell you how many sols it has been on Mars, not how many Earth days, because they're counting time differently on Mars. And so I think when we go to Mars, we'll use the Martian clock as our clock.
Sure. Well, I'm gonna throw some spanners in the work for you. I had some email questions, and I have absolutely no idea what they're asking in one or two of the questions. So let's see if you know. The one question is from Davin Page, and he wants to know, what is the Alcubierre white warp drive, and how does it work?
Okay, could you repeat that? I got everything but the last three words.
Oh, how does it work? What is the Alcubierre white warp drive, and how does it work?
The warp drive that Harold White is working on, I think, is what he's referring to.
Yep.
So, Harold White is an engineer here at NASA. He's actually my neighbor here in Houston, because we all work for NASA, right? And he's a very good theoretical physicist. He's a lot like those guys on the show The Big Bang Theory, if you watch that. And he's very interested in making a big physics breakthrough in how people move around in space. Because right now, the kind of chemical engines that we use on spacecraft, we've sort of reached the limits of our technology on chemical propulsion. So what Dr. White is doing is he's looking at the kind of technologies that they use on science fiction shows like Star Trek, where they're actually bending time one place to another, rather than expending large amounts of fuel. And he has an experiment to see if he can do that. And he has designed, and you can look at his designs for a warp spaceship online. It's really cool looking. He has an experiment to see if he can fold space and time. And it's really amazing. I've been in his lab and I've seen it all, and he hasn't tried it yet. And I'm going to be far, far away when he turns it on, because he's either going to win a Nobel Prize or create a small black hole in his laboratory.
Wow.
No, but it's a very interesting physics problem, and it actually involves a lot of math and science. Most of the work he does is literally on a a whiteboard scratching out equations on how this works. And the actual experiment itself is pretty simple compared to all the math that goes behind it. So you may hear at some point in the future where NASA has done an experiment where we try to make warp drive work. So
sure. So it was a great question. That was a great question. And then we had another question from Steve Dreyer, who wanted to know, what is NASA planning on doing about the global dust storms that occur on Mars?
Okay, so that's a good question too. So Mars, if you look at it through a telescope, you'll notice it's kind of orange. It's rusty colored because it's covered mainly in iron oxide, which is rust. And the dust on Mars is very, very thin. And so even though Mars has a very thin atmosphere, typically typically twice every Martian year, we get dust storms. And the dust storms are caused by all the gases that were frozen into the polar caps on Mars, which is dry ice. It's frozen carbon dioxide. As all that warms up and all that dry ice becomes carbon dioxide, it wants to move down through the rest of the planet because it's creating a lot of gas. And so as all that big gaseous bubble of carbon dioxide moves down through the planet, it picks up dust, and we get these planet-wide dust storms. Now, a dust storm on Mars is much different than a dust storm, here on Earth. First of all, because the atmosphere is so thin, it can't really pick up dust particles that are very big. In fact, the biggest dust particle that you see in a Martian dust storm is about a micron particle, which is about the size of a Martian dust storm would never have anything in it like a grain of sand or, big particles that you could even feel. It would basically look like a smoky day. Okay, so when you see movies like The Martian, which starts out with this big Martian dust storm and there's big rocks being hurled and all that, that could never happen on Mars. A bad dust storm on Mars will look like a smoky day, like there's a fire. And in fact, you won't even feel it blowing against you because the atmosphere of Mars is only 1% of the atmosphere of Earth. Even if it's moving very fast, if the Martian atmosphere is moving very fast past you, you will barely notice it as a very light breeze. So a lot of times Hollywood, does things to make movies interesting, but the reality of Mars is that dust storms are, it's going to be a little darker. It's going to darken out a little bit of the sky. It's going to put a lot of kind of dust on your solar rays and on your equipment, but it's not anything like the dust storms are here on Earth.
Okay, so now I know that we have run out of time and there are still loads of questions and people have got lots of things they still want to ask, and that's always a good thing that people are still interested and engaged, and that's, for me, that's, as an educator, there's nothing greater than having people who just are thirsting for more. So I'm going to give each of you guys one more question because I know that John's a very busy guy and we don't want to keep him for too much longer. So we're going to hit Natasha. What's your final question?
Hi, my name is Tess. My question is, with the privacy issues, how private is it? How private are the sleeping rooms and such?
Okay, good question. So privacy is a big issue when you're in space and you're living in something the size a caravan with 5 of your closest friends. We try to give every crew member a private area so that they can sleep if they want to, or so they could just close the door and do email or talk to their family. That's very important. Communication with people back on Earth is important. And so every spacecraft that we think about where we're sending people into deep space, we'll always have private areas for each of the crew members, so they could have that private space. And I know this very well because my wife is a space architect, and she tells me all the time that it's very important for crew members to have their own space. So,
well, that's always a good thing. In space, you should have space, always. Okay, then we're going to go to the Ivory Coast. Do we have one more question on that side? I know Mr. McNulty's group had to leave, and they said goodbye. Any more questions?
We're here. We have one more from one of our classmates.
This is on behalf of Amy Moten, and she is saying, what qualities are sought for space explorers? Like, what qualities do you need to have?
What qualities do explorers need to have?
Yeah, I think she's asking for a friend, if you know what I mean.
Yes, I know, Amy. And Amy was very, very brave to ask that question. So as I heard it, is what qualities do explorers need to have? Well, certainly bravery is one, because you're going to be out there in an environment that's not exactly safe. Adaptability is very important, because things are going to happen that are not going to be exactly the way you have to know how to adapt. I'd say the ability to be a good team member is very important, because you and the 4 or 5 people you'll be with are going to have to get along all the time, and you can't be one of these people who gets into arguments easily, or or sulks out. You'll have to be able to get along with people and work with them, even if the situation is maybe a little bit bad. And then I think there's a great deal of curiosity you have to have, because to be an explorer, the reason you're an explorer in the first place is because you're curious about what's out there. So you've probably, because you're that kind of person, you've probably gotten a degree in something like science or engineering. And that's about how things work, or how nature works. And so I think all those things together are the kind of traits that a perfect explorer would have to have.
Awesome, awesome. So now I think we're going to end it here, but before we do that, we need a big smile from John looking at the camera, and we're going to try and capture a screenshot. Hopefully the screen resolution will be good at the time that we get it. Let's try another one over here, because I see that with the iPad, obviously you're reliant upon the Wi-Fi signal, and that depends on how many people are using it. And we'll get a capture one of Kim and her group over there as well. Big smiles. There we go. And I see Donnie will get one of you as well. I did get one of you and your son earlier. And of course, Natasha, we've got your group over there. We're missing your camera, or for some reason, I do have a picture of you, so don't worry. And we'll get one more of John. Now, there he is. He's back. Let's see. We've got one of him and R2D2. So I was going to ask you one quick question. I was going to say Star Wars or Star Trek?
Both.
Okay, good answer. Good answer. Well, John, thank you so much for giving of your time. I know that for the Humans to Mars Summit, which is coming up on the 8th to the 10th of May, we're going to be trying to share the message that Mars is really happening. It is a reality. It's just not a case of if, but rather when. And it's also not a situation where you are going to be sending people to a planet and like a Mars 1 mission where you are where it's going to be a one-way mission. That's not the way NASA operates. You guys obviously want to bring them back, and I think that's critical. That's everything. Buzz Aldrin, you know how big the whole moon landing was. You probably got to meet Neil Armstrong as well. Can you imagine being the first person to step on Mars? That would just be gargantuan.
It would be. It would be a good exercise for all the people watching there. What would be the first thing you would say when you took that first step on Mars?
You'd have to rehearse something, and then who would be the Michael Collins of the group flying around, who, you know, there are a lot of tough aspects to it. But I'm sure that a lot of thought is going to go into this particular mission. And who knows, maybe even Elon Musk gets there before everyone else.
Maybe.
Maybe.
Or maybe,
So John,
maybe a red Tesla crashes into Mars first.
Well, thank you so much. And thank you, Kim and Dondi and all the others. We had all the international viewers who are watching it live. We really appreciate that you joined us. And we hope that you learned something new. And if you have any other questions, send them to me and I'll email them off to John. And hopefully, if he's got some time, he'll take a crack at a couple of them as well. But thank you so much and bye-bye, everyone. And I'm going to stop the broadcast over here.